Today we're doing area of a minor segment. I haven't, but that's fine. Alright, so this is a formula that I'm pretty sure is found on your formula sheet. I could be wrong, but to find the area of a triangle, it is half AB sine C, where A and B are the sides and C is the angle that is in between them. So with this, I'd have half times 1.7 times 1.5 times sine 65. Yeah, I type it in my calculator, get some number. Happy with that? Okay, we're going to be using that today, so we've got to remember that formula. Oh, that was just the warm-up, Ella, sorry. So the area of the segment, so the formula to find the area of a segment is not on the formula sheet, okay? So it's the only one that's not on it. So we've got the arc length and we've got the area of a sector, but we don't get the area of a minor segment. So here, as it says, it uses the trig formula for the area of a triangle. Now, as long as your C is in terms of radians as well, that sign will still work. If you have one in radians and one in degrees, you stuffed yourself. Okay? Just make sure they're in the same terms of things. So here, if we have this circle from last lesson, how do we find the area of the sector? Yep, half radius squared theta. And we want to take away the area of the triangle, which is this half. So that would be r squared, yeah? Because r times r, each side of the triangle, because that's the sine theta. Yeah? So you see that the half r squared is in both of them. So I can take that out as a common factor, half r squared, theta minus sine theta. And that's the formula we're going to use today. Okay? If you want, you can use that one above, but it just saves you putting half r squared theta, r squared in twice. So that's it there. Beautiful. And remember, they both have to be in radians. Okay? So, examples, and then you can have a go at it yourself. So find the area of the minor segment formed if the angle of pi on 4 is subtended at the centre with radius of 5. So I just whack it in the formula. That is half times 5 squared, bracket, pi on 4 minus sine pi on 4. And I just type that in my calculator. Woo! There's cake there, Jack. So 0.5 times 5 squared. That is not a square. That's not a square. Oh, where's the square button? Okay, 5 squared. Pi on 4 minus sine pi on 4. Now remember, your calculator has to be in radians for this to work, which my calculator is not. Okay, rad. So, I don't want to hear that, Bridget. I hope the thing didn't hear that. Okay. Bridget. Okay. Did anyone get an answer for that? Did they attempt putting that in their calculator? What'd you get? Huh? 0.39. Can someone else do it in their calculator, because we've gotten different answers? So make sure your calculator is in RAB.
If it's just a segment, it's the sector.
So basically, it's like got this is pi on 4, it's this little part here. So I'm finding that coloured in bit. What did you get?
0.978.
That's what I got. 0.97 blah 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 blah.
Yeah.
What? Yeah, I wrote blah 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 though. That's alright. So 0.98 meters squared. Yeah? So Izzy will go check your calculator afterwards. Okay, so here we've got another one. We've got an 80 centimetre piece of wire bent in a circle shape. So this whole way around is 80 centimetres. Nice bit of wire, that's a nice circle. And a 10 centimetre piece of wire is joined to it to form a chord. So here we've got, woo, that thing is 10 centimetres long. Yep. Find the area of the minor segment cut off by the chord. Alright, so the first thing we might need to do is find the radius, or the diameter. So how would I do that?
Divide 80 by 10.
Yep.
Yes.
But remember we want it in terms of radians. So how many radians is a whole circle? Perfect. So my radius is going to be 80 over 2 pi. Okay, so now I've got this here, pretend that's the centre. That's terrible, that's not the centre. But that's 80 over 2 pi. Yeah? Okay, how do I find the angle in here? Yeah, it does. I've got 3 sides of a non-right angle triangle. How do I find the angle in the middle? 80 over 2 pi, because our formula up here for arc length is r theta, where theta is the whole revolution of the circle, so it's 2 pi, because it's the whole way round. So here I had 80 equals r times 2 pi, so I just divided it to get my radius. 2 pi, because the whole way around the circle is 2 pi in radians. 2 pi is 360 degrees. Yeah? Alright, so now I've got 3 sides of a triangle and I need to find the angle that it makes. Perfect, cosine rule. Oh, sorry, Alice. So, who remembers cosine rule? Well, it's on our formula sheet, so a squared plus b squared minus c squared over 2ab. Perfect. So now we're going to sub all the bits we know. So we have, yeah, this is us finding this angle in here now. This one's, yeah, a long question. So a is 80 on 2 pi plus 80 on 2 pi minus 10 squared minus 2 times 80 on 2 pi times 80 on 2 pi. Yep. Isn't that the nicest looking thing? Is it? No. C is this angle in here. Okay? Sorry. I was just burping. So, I don't know if we can keep this in terms of pi, but let's give it a go. 6400 over 2 pi plus 6400 over 2 pi. I mean, not over 2 pi, over 4 pi squared. I know, right? I just squared the whole thing. Minus 100 over 2 times 80 times 80. 12800 over 4 pi squared. Ugh. 80, because 80 was here. Yeah. Yeah, well, it says correct to 2 decimal places, so yeah. Let's just work it in our calculator. So that's an ugly thing to type into a calculator. So let's go to Miss Mabry's and see what she wrote, so we can just copy it rather than type it. Oh, she didn't do it. Miss Mabry. They did this last lesson, so I thought it'd be filled in so I wouldn't have to type this in my calculator. 6.915 blah 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 is cos C. So I need to go shift cos of 6.915. Make sure I'm in rad because we're doing all these formulas in rad. Of 6.915. Error 2. Yes. I keep getting error.
1 second.
So wait, this is going to be our test.
Yes. Okay, let me try this. So 6400. Okay, this is a really hard question. Yeah?
There's not really anything like that in the...
No, there's nothing really like this in the exercise.
Question 7, 11, like how you got 8, 9, 10, 11, 12. Theta equals 180. Still stuck. Theta equals 360.
Well, if it's the circumference of a circle,
Yeah.
and for me to find the arc length, the formula is pi
Yeah.
r, or you know what I mean. The angle the whole way around is how many radians? Because we got the whole circumference, it said the circumference is 80. So the whole way around that circle is 80.
Yeah. So wait, what are you trying to find with that?
The radius.
Oh.
Okay. Yeah. So I'll fill the rest of that in later because stuff's typing that in my calculator. You'll notice all the ones in here, you start getting to those kind when you hit like, maybe 9. So just have a go at, so question 1, every second one, question 2, every second one, and then do 3 to 11. Alright, do you want me to make that bigger? So just starting off with those easy ones, I'll write the formula on the board too, yeah, and we'll whack some tunes on.